Hello and welcome back to the Inside Java podcast, a podcast about everything Java brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog and I recorded this conversation with Ron Pressler at JavaOne 2025 as part of a live stream to our YouTube channel. Ron Pressler is a Java architect at Oracle and probably best known as the lead of Project Loom, but we talked about something else: integrity by default. It underpins all of Java's guarantees like memory safety, type safety, encapsulation, and many more. But what is integrity exactly? Which Java mechanisms can undermine it? What does it mean to be on by default? And what can and should developers do when dealing with it? Ron and I went over all that. Enjoy the episode. What we're talking about today is another push that I think happened independently of you, but you kind of coalesced into an idea, right? The idea of integrity.
Yeah, I volunteered to do some things that we thought might not be the most popular things. So.
Oh, that's why they did after Loom. So you're good guy Loom, and then you're bad guy integrity.
I had some credit to burn. Yeah.
Okay, yeah, because I thought, isn't that Mark's role to do the stuff that nobody likes?
Maybe, but he's busy with other things.
Yeah, okay. So then let's talk about integrity by default. I think it's important there to make a point. Yes, it might feel to the users or to the Java developers as, you know, something that they might not like, but there's actually a big upsides there that are very important. So yeah, why don't you describe what the idea is about, and then we can talk a little bit about how it impacts Java's development kernel.
Yeah. So first of all, thank you for having me. The way I presented in my talk, Brian likes to call certain features jetpacks, and other features are seatbelts, and everyone's happy with the jetpacks.
Yes.
I know ZGC, virtual threads, FFM and all that. The seatbelts are sort of like safety features, but they're very important to be able to do other things. And the work on making the JDK have more integrity, and I'll speak in a moment what that means, started out around JDK 9, but it's been progressing. And soon we will want to have features that depend on it being in place. That's why it's important to start this work.
Okay.
Now.
Yeah, so let's cover those features a little later. Let you first tell us what integrity is and then why it's important.
So integrity is the ability to make certain guarantees that everyone can trust. And both people reading the code or writing the code, as well as the runtime itself. For example, in a C program, you should never access array outside of bounds, but it's not guaranteed. In order to know whether or not that happens, that is a desired property of a program, to never access array outside of bounds, but to know whether or not that's the case, you have to analyze the entire source code, including the dependency. In Java, that you can't access arrays out of bounds is guaranteed. And so that property has integrity, the property that you don't access arrays out of bounds.
Right. So I think, just to clarify, so in Java, if you go beyond the array bounds, you get an exception.
You get an exception.
And in C, you just read potentially weird memory.
You don't know what happens. Anything can happen.
Exactly. So that's the point, right? So we're not saying that so the exception is good in that sense, because it says you did something wrong, and you don't get silent misbehavior.
Yeah, nothing happens other than, the exception stops you from doing anything. So that is integrity, but that property is enforced by the JVM itself. Although you can ask yourself, is it always true in Java? And that's all starts showing, the crack starts to show. For example, some people use the unsafe class. You can access an array out of bounds using unsafe.
Right. True. I was going to say like how though, but yeah, right.
If you use JNI, you can access a Java array out of bounds. And that starts showing already some of the problems. But another question is, can Java code create its own invariants, its own desired properties that have integrity, that are guaranteed? And the answer is that in many situations, you want to be able to, and you almost do. The classic case is using encapsulation. So if you write a class and you want something to always be true about its internal values, like a number is always even, you make it private, and you only expose a constructor that makes sure it's true. You expose public methods that maintain that invariant. And as long as Java's access control has integrity, no one can mutate your field, your private field, without your permission, then your bigger property has integrity. The problem is that access control doesn't have full integrity in Java, again, there are features, deep reflection, that can undermine that.
Yeah.
And the ability to trust invariants is important both for you as someone who writes the code and wants to make sure it works. It's especially important if what you're writing is some security mechanism. It's important for everything, but in security, it's easy for people to understand because you want your property to be robust. You want it to hold true no matter what other code in the program does.
Yeah.
And in the old days, any piece of code in the program, including a fourth level dependency, you don't even know about it, some library dependency or dependency or dependency, decides that they don't like your invariance and they want to change it.
Yeah.
Never mind why, we can talk about it later, but for some reason, if they want to, they can break all your invariants. An example I like giving is strings. Are strings immutable in Java? Yes, unless some code decides to change them.
Yeah.
They could through JNI, through deep reflection, through unsafe. And it's not just people who need to trust it, it's the Java runtime itself. If the Java runtime can't trust that strings are immutable, that final fields are immutable, then there are certain optimizations that it can't do.
Yeah.
And that's where, and that is integrity.
Okay, so you mentioned the example you mentioned with the even and odd numbers, or with security relevant things. That sounds like almost too trivial to be important. But the reason for that is because while, or at least I think that the reason for that is that while those things hold to such a large degree that you basically, I think our perception as Java developers is that I can already 100% rely on those. So we already think that we can, even though technically we can't. And then occasionally something happens that shows that we can, and we consider that like a fluke situation that shouldn't happen. But the fact that it can happen is already the problem. And then in security spaces, specifically becomes, as you said, almost obvious why that could be a problem.
Yes. So there are two examples. Again, in a talk, I think maybe even others, but two examples I think worth mentioning. One is for the Java runtime itself, especially the JIT compiler, to perform certain optimizations.
Yeah.
That something is true with high probability is not good enough.
Yeah.
It has to be 100% certain. But even for code, especially security code that you want to know is correct, there are situations, in fact, there have been security vulnerabilities that happen not because people want necessarily, we're only talking about benevolent code, well-intentioned code.
Yeah.
There are bugs that allow a remote attacker to manipulate a good library that uses deep reflection to break certain important security invariants.
Yeah.
But again, it's not, security is a good example, but it's true for anything that has to do with correctness, that you care about correctness, or performance optimizations by the runtime.
Yeah, and also as I said, like it could just be a bug, right? Like it doesn't have to be nefarious that something breaks an invariant. It can just be a bug in some code that does deep reflection and it does unintended effects.
Yes.
Okay, so now that was very academic, so to speak. So we talked a little bit about why that's important, and we also talked about how which specific mechanisms can undermine that. Did you enumerate? Because you said, for example,
no,
but
so, okay.
pretty much enumerated them. Right?
There's deep reflection, so specifically the set accessible method. There's JNI.
Yeah.
There's unsafe.
We should FFM probably also, right? Like
I'll get to it.
Okay.
So deep reflection, JNI. There's a difference between JNI and FFM because JNI is similar to deep reflection in the sense that it can access fields and call methods. With FFM, it's a little bit different.
Okay.
Agents. An agent can change any code to mean whatever it wants. And did I say? Yeah. So deep reflection, JNI, agents, and unsafe.
Yeah.
And then you have FFM. So FFM, the only risk there that it can't really change any Java invariants, but it could cause undefined behavior in general. And we'd like to have most Java programs be free of undefined behavior.
Okay. And on because you said this move towards integrity started with modules, and that probably tackles the deep reflection part, right? Because modules basically said, okay, well, unless you allow it in the command line, deep reflection of JDK internals or generally of modules is a no-no. You cannot do this anymore.
Right. That started in JDK 16. Some people think it started in 9, but it was only turned on in 16.
Yeah, true. Good point. Yes.
So in JDK 16, it was turned on, and that was the beginning because it blocked deep reflection. But the other mechanisms remained.
Yeah. But the important part there is, while deep reflection is disallowed, it's not disallowed entirely, it's disallowed by default. I can still say no, I know better. So it's like reflecting over Java lang, which is risky, but I will allow that for reasons.
Right. So that brings me to, I think, one of the most important points. So I talked about what is integrity. Now I want to talk about what is integrity by default.
Yeah.
So many times people have, so when you write a piece of code, you want to maintain certain invariants, certain properties that are always true. But the users of your code, sometimes they have good reasons to violate them.
Yeah.
It could be maybe you stopped maintaining your library and they don't have your source code and they want to work around a bug. There are cases.
Yeah.
They should be relatively extreme. There are situations where they're actually more common, like mocking libraries.
Yeah.
So if you mock things, you want to mess around with internals. So that's so for testing, there are some reasons for serialization, not very good ones, but
I mean, that's the thing, right? In a gigantic ecosystem as Java's, even rare cases happen in absolute numbers. That's pretty common.
Right. So what are we saying? We're not saying that these things are forbidden.
Yeah.
We're saying they're forbidden by default unless you allow them. Now, the question is, who is you? And you, and that's with everything, especially in security, but even in software engineering, the question is, who can do what? The person who can choose which integrity invariants to allow, selective breaking of, is the owner of the application.
Yeah.
And who is not allowed to do it? The libraries.
Yeah.
And the reason for that is that you can think about it in the abstract sense. You don't want any fourth-party dependency deciding for the library that it's going to mutate, for the entire program that wants to mutate strings. But more concretely, the biggest problem, the biggest cause of the migration pains from JDK 8 to 9 plus was libraries, mostly low-level libraries, reaching into JDK internals that were not covered by Java's backward compatibility.
Yeah.
And then there's internal change and applications broke.
And they didn't know before.
And they didn't know.
Yeah.
Now, it's possible that those libraries had to do those things to offer certain functionality, but they made a trade-off. They made themselves non-portable, but they also made all of their consumer libraries consumer applications non-portable, and the applications didn't know that. They didn't know they were making the trade-off. So a fourth level dependency just actually made your entire application non-portable. It couldn't upgrade the JDK. So integrity by default says a library can decide that it needs to do whatever it wants, but it has to inform the application and ask for its permission.
Yeah. So what when we talked about the importance of integrity, that case that you just mentioned, actually, we didn't include that, but it's also an important part of integrity, because if you break the integrity, for example, by using internals of something, and then that those internals evolve as they're allowed to, then it doesn't, using those internals might not cause any problems on the JDK or library dependency version, whatever that you are on, but they might cause when you migrate and the internals change, and then because of this violation of integrity, you're now in a situation where you basically have to do extra work.
Right. Yeah. And this maybe that's a good point to mention. So one of the flags, one of the oldest flags, used to break open the strong encapsulation, or for deep reflection, was add opens. And some people think that if they put add opens, that means they're working like in old mode and everything will continue working. That is not the case. The reason why programs broke between 8 and 9 plus and this encapsulation wasn't turned on then is because internals changed. Yeah. If you have add opens, it means that you have a risk you will break eventually. Yeah. So it's not, it just notifies you of risk and of an underlying problem that you need to solve. This is something that I need to fix. And the risk you're taking is, or made up, so it could be performance risk, it could be a security risk, and it could be a portability or maintenance risk. Yeah. And what integrity by default does say is you can't hide those risks from the application. The application has to say, okay, in this configuration, I'm deciding willingly to accept those risks.
Yeah. Yeah, because just to 100% clarify, because it is the application owner who takes on that risk. It's not the library. The library is not at risk because the library can say, well, if the internals change, I just release a new version. And for the library perspective, there's very little risk if it uses an internal API, for example, whereas it's the application owner that takes on that risk of having the application stuck. So that's why it's the application owner who should always be the person making the decision like, yes, I'm willing to take on this risk because I see the benefit. And it's also something that I have to admit that annoys me a little bit when some libraries say, oh yeah, just add opens all unnamed. I'm like, first of all, please be a module and please tell your audience or your users add opens just to my module. If you're using me on the module path, that should be the default. Add opens all unnamed should be like the next best. But also tell your audience why. What are the trade-offs? Why are you doing this? So that they can read. I'm a little bit worried that such low-level dependencies will train Java developers to just blindly accept those flags without really making the conscious decision that you just outlined. I'm taking a risk. Let me evaluate how likely this change is, because you say all of that will change eventually, but there's very many parts in the JDK that don't change a whole lot. So somebody could look into like, do I expect change there? Or also, is it worth it for me? What do I get? And I'm a little bit worried that the ecosystem or the community starts to like evolve to just like, hey, I just add those flags. It'll be fine.
And well, it's not. It is a problem, and I agree with everything you said. But it might be a bit of a digression. But you said everything should be a module. I'll just say. People might not know this, but to make a jar into a module, all you have to do is put it on the module path. So instead of...
Well, then it exports everything, so... Yeah.
It exports everything, but then your decision on which flag to do, add opens, or I didn't mention enable native access, that's for FFM and JNI, it's much more fine-grained.
Yeah.
The problem with that is that currently, you can't just take the class path, let's say using -cp, and drop the C, and everything will work. That is not the situation at the moment, but we might be changing that so that if you have a class path, you'll just be able to drop the C and turn the class path into a module path. I mean, the same as you can today, but to make it work transparently without having to add other flags like add modules. It's something we're considering, and that will make it easier for people to just move a jar from the class path to the module path.
Okay, that's interesting. We're close to being done, but let's briefly run through those examples that you gave. And just briefly though, what happens in JDK 24 or currently what's going on? What's the current state? So we talked about internals, about strong encapsulation, and that modules in JDK 16 turned that knob, and now it's at opens or at exports. You have to add that.
Right.
So that seems to be settled.
Yes.
Then agents.
Right. So all the other mechanisms are right now at the stage where they just issue warnings, and they will remain that way. I don't know if all the maybe agents will turn into an error in 25. Not sure about that yet. But if you try to you can always add an agent on the command line because that shows intent. But loading it dynamically will issue a warning. As of JDK 23. There is now a warning if you use JNI, unless you pass the enable command, enable native access, same as for FFM.
You said 23, you mean 24?
No, I think it's 23.
Then 23 like
JEP
this?
471.
Okay, maybe you're right.
That's
the details.
No, sorry. Yeah, it could be. No, JNI is in 24. I think you're right.
Details, because the 23, the FFM used to be an error, and JNI used to be I don't care.
Right.
And now they're united under one flag that says, well, they're both a warning now. So actually, FFM got more relaxed, and in the future will get stricter again.
We try to make them the same. Yeah. So I think you're right about JNI, JEP 472. That might be in 24. So for JNI, you'll get a warning. For an unsafe, we're starting the removal process of most of its methods. I think that went in 23.
So deprecated for removal are a bunch of unsafes, memory access methods.
Yeah, I can't remember. In my mind, we're already in JDK 26, right? So we're at the end of 25, right?
We have 3 more months on 25.
Yes, but yeah, you know, we're getting our ducks in a row for 25. We're already thinking beyond.
So quickly explain that. Why did I say we have 3 more months for 25? You would think, wait, isn't that 6 months away? Yes, but in 3 months, OpenJDK says, you're done. You didn't give me your feature. You have to wait for the next train. So that's why we're like a little bit time shifted. OpenJDK's things that 6 months goes from January to June, roughly speaking. Not from March to September. Yeah,
so I can't remember which feature went into which JDK version, but I know the current state.
On you.
So the current state is you get the current state has a JDK 24. You get a warning for using most unsafe methods. You get a warning for JNI. JNI is a bit different because JNI is like FFM. You just have to add that flag. Unsafe is different because it's going away. Right.
Yeah.
So it's not like add this flag and everything will work. You can suppress the warning, but you will have to take care of it.
Yeah. But I think the gist here is that ideally, most applications have to do none or very little of that, because most applications do very few of those things. But if you do ever encounter documentation that tells you add this flag, add that flag, be aware that you're making a conscious decision. Potentially, I mean, it depends on the flag, right? But many of these flags, you make the explicit decision to take on risk, or rather, you make the decision, make it an explicit decision. Make sure that you know what's going on.
Yes, exactly.
Okay. Thank you for being here, Ron. Next time we meet, we're going to talk about more fun stuff, like the on-ramp, for example.
This is fun too. Actually, it lets us do many things.
Okay, it's fun too. We didn't talk about the downstream benefits, like optimizations, for example.
Optimizations, but primarily, we did mention it allows us to make big changes to JDK internals without breaking applications.
Yeah, at least without breaking the good ones. Okay, good. Thank you.
Thank you.